Today we're starting a new unit on fractions, decimals, and percents. Today's lesson is going to be about representing these fractions, decimals, and percents as either a set of blocks or a circle that is divided into equal parts. Now let's get started. Okay, first some key terms. You have to know what a fraction, a decimal, and percent are before you can start representing them, converting them, comparing them, and doing all of the other things that we're going to do with them in this unit. So a fraction is just a number that shows part of a whole. You guys all know what a fraction looks like. It shows part out of a total. A percent and a decimal are two other ways of showing part of a whole. A percent shows it as part of or out of 100. That is an important phrase, and we're going to be using that a lot. A percent means out of 100. And a decimal uses place value to show part of a whole. It does tenths or hundredths or thousandths. The difference is a fraction can have any denominator. A fraction can be eighths or ninths. A decimal cannot. A decimal needs to be written in a way that shows a unit of 100 or 10 or 1,000 or something like that. The other thing that we're going to use in this unit are fractions that are written as improper fractions. That is when the numerator is larger than the denominator. And we're also going to use mixed numbers, which is another way to write an improper fraction that shows a whole number and a fraction next to each other as a total. Okay, so let's get into the first part of this lesson. Representing fractions. This is fairly simple to do. If you want to represent a fraction, you make a picture that has equal sized units, and that number should be equal to the denominator in the fraction. And you should shade in the number that appears in the numerator of the fraction. So here we're showing the fraction 8/20. I have 20 boxes. All of them are the same size. They're all connected as one big piece. It's a rectangle that's cut up into equal size smaller parts, and 8 of them are shaded in. So that represents 8/20. Okay? We're also going to show how you can use the same size box cut up into different numbers of pieces to show this same value written in simplest form. What you guys remember from elementary school is that and from your other units this year, is that when you want to simplify a fraction, you divide the numerator and the denominator by the same value. So here, 8/20, if we divide both values by 4, we can simplify that fraction and have it have an equal value, but the numerator and denominator will be smaller numbers. So here, 2/5 is a simplified fraction for 8/20. Let's see how that affects the representation. Here we have two equal-sized rectangles. This rectangle is broken up into 20 equal-sized blocks. This one is broken up into 5 equal-sized blocks. In the top fraction, 8/20, we have 8 out of 20 shaded in. In the bottom one, we have 2 out of 5 shaded in. That's just the simplified version of 8/20. So what you can see is if we took away all of those lines and you just had a rectangle there with some orange, the rectangles would be the same size, the larger rectangles, and the amount of those larger rectangles colored in orange would be the same. So here you can see the amount of orange is the same in both pictures. What this shows is that 8/20 and 2/5 mean the exact same value, but are just shown here in different ways, and in fraction form they're just written with different numbers. So let's say you're cutting a cake up into pieces. The top one, you're cutting the cake into 20 pieces, and you have 8 of them that are eaten during a meal with your family. Here you have a cake that's cut into 5 pieces, and 2 of those pieces are eaten with your family during a meal. If the cakes are the same size like they are here, 2/5 of a cake and 8/20 of a cake would be the same amount. So if 2 families decided to cut the same size cake up differently like this, but ate the orange amounts, those 2 families would have eaten the same amount of cake. What that tells you is that those 2 fractions are equivalent. They're equal. Okay, so let's do some practice. Hit pause on your video. Do what the directions tell you to. So in the first fraction, draw a picture of it and shade it in. Try to draw it in simplest form too and see if you can. And for the second one, I just want you to tell me what fraction is being shown and then simplify that fraction. Okay, so what you should have done here is drawn a picture of 10/12, 10 shaded in blocks out of 12. Make your blocks as close to the same size as possible. I know you don't have rulers with you probably right now, so it's hard to make them exactly the same size, but try your best. If you had taken away the line that cuts through the middle here, you would have made a rectangle that was broken into 6 pieces, and 5 would be colored in. And that would be the simplest form of that picture there. The one on the right, 6/8 is what you see. If you divide those by 2, you get 3/4. Okay, and you can see here what I was saying earlier about the simplest form for this first picture. If I just erase that black line that goes to the middle, it would turn into this picture, and that would be kind of like simplifying the fraction. That would turn the 10/12 into 5/6. Okay, just something here for review for you. We're going to talk about decimals next. Place value is not something that you should be taught in 6th grade. It's something you should come to 6th grade with. You should have that knowledge. This is here just as a reminder and something for you to look at if you need help remembering some of them. So here is your decimal point. To the left of the decimal point are whole numbers. You have your ones place, your tens place, your hundreds place, so on. In the other direction, you have your decimal place values. So you don't have a one place. There's no such thing as a 1th place. You start with tenths, hundredths, thousandths, 10,000ths, and so on. What you can see is other than the ones, this right side is a mirror image of the left side with a THS at the end. So if you know your place value is going to the left, you should know them going to the right as long as you don't put in a 1th value here, because that doesn't exist, like I said. Okay, so let's talk about these. We're going to write a decimal and show it through picture form. So the same kind of, it's very similar to how the fractions are, except with decimals, like we said before, if you look at step 2, decimals have place values of tenths, hundredths, thousandths, etc. So that's how many blocks you're going to draw in your picture. You're going to use the actual value of the decimal to color in a certain number of those blocks. So let's take a look at the first example. Here we have 10 blocks and 7 are shaded in. So since there are 10 blocks, you know that your decimal place value is going to be tenths. And if 7 are colored in, you can just simply say and write this picture as 7/10. If there were more than 10 blocks, like 100 or 1,000, then you would say it differently. But 7 out of 10 is 7/10. And it makes sense because if you did write this as a fraction, you would write 10 as your denominator, and you would write 7 as your numerator. And you would say that the same way you say this, 7/10. Okay, so here's another one. If you want to take a second and count all the blocks, you can, but remember, you can get a total number of blocks in a picture by counting the ones that go sideways and counting the ones that go up and down and multiplying those numbers together. So here we have a 10 by 10 grid. So there are 100 total blocks in this picture, and out of those 100 total blocks, you can count that there are 57 shaded in. A quick way to count the ones that are shaded in is every column counts as 10, so you have 10, 20, 30, 40, 50, and then there's 7 here, so that's 57. So the way you would say this decimal out loud, or if you're writing as a fraction, you would say them both the same way. You would say 57 hundredths. And in decimal form, the way you write that number is 0.57. 57 hundredths is 0.57. Okay, so now we're going to do percents. Since the word percent means out of 100, you need to either have a picture that has 100 blocks like the last one, or right now, if we're just doing representations, we're not actually converting numbers yet, you have to try to change the number of blocks in the picture from some number to 100 by multiplying. So you need a factor of 100. So factors of 100 would be like 2, because you could do 2 times 50, 5, because you could do 5 times 20, 10, because you could do 10 times 10, 25 times 4 is 100, 20 times 5 is 100, like I said. So if you have any of those numbers, you can multiply the number of blocks in your picture to get it to 100 to make it a percent. So in this picture here, we already have 100 blocks, and if 57 are colored in, it's the same examples we had earlier, the picture is just representing 57%. It's that simple. So if you can remember that percent means out of 100, writing a percent is really not that difficult. Here we don't have 100 though. We have 10 blocks. We had this example earlier, right? So what you have to think to yourself is, what can you multiply 10 times to get to 100? Because if you can do that, you can multiply the 7 shaded ones by 10 also and figure out what percent you have. So here, if there's 7 shaded blocks and 10 total, what we know is that 10 times 10 is 100. So we can also do 7 times 10. And if we do 7 times 10, we get 70. So since 7 became 70, the picture represents 70 out of 100, which equals 70%. Okay? So that's that. I hope you enjoyed the lesson today. I hope it wasn't that difficult for you. We're going to talk about how to convert these as math problems next lesson. So use this for practice, use it for help with your homework, watch it again if you need to, use it to study for quizzes, and we'll see you next time.